Alrighty, let's start. So I'm doing, if you saw, I'm doing two talks in a row. So this is the segment on Cypher. So we have one slot where we want to talk a bit about how we design Cypher, how we go about that, and of course talk a bit about the whole process that's happening. That's the first talk, and then there's going to be a second lightning talk on the Open Cypher project and what has been happening there since the last Graph Connect, right? So yeah, how do we design Cypher? I'm assuming, but just to make sure, right? Who here hasn't worked with Cypher or isn't aware of Cypher? Right. Okay. Then this slide is for you, and we'll talk it over, right? This is perfectly fine. So Cypher is Neo4j's graph query language. So that is the piece of technology that is used in order to get data in and out of the graph, right? And here we have a couple of sample queries already. Right, it's very visual, it's very in your face. You kind of, you can create a node, a person, right, with some attributes, and then you can find it again, right? And the key characteristic you can already see here a bit. It's very visual. It's almost as if you had drawn it on a whiteboard, except it is done with ASCII art, right? So that is our query language Cypher, and yeah, so how the hell do we design this, right? If you take a step back and think about Cypher, then maybe you could come up with this list of traits that I think can be found in Cypher, right? And one is it's visual, and perhaps more importantly, it's human readable, right? One of the goals of Cypher has always been to be a very, very human readable language that is not too technical, right? That's really, you can use it, you can work with business analysts, you can work, of course, with engineers with Cypher, right? So, and that's reflected perhaps most prominently in the graph pattern side of things. That it is declarative, like a good query language should be, right? We aim to be very uniform, so that things fit together and you don't have, very kind of non-matching syntactical constructs. It's also high level. What's meant by that is we want to be at the right level of abstraction. We don't want to be at a level that is too technical. We want to be at a level that fits your domain. That's more geared towards the domain than it is geared towards the implementation of things, right? It's implementable, of course, right? Otherwise, you all wouldn't be here today. Another thing is, sometimes if you go to academia, you find these debates about, should languages be decidable, should they be Turing complete and all that, right? Our stance on this has always been, if there's a feature that potentially blows up in cardinality, right, then you should only pay its cost if you use it, right? So our stance is not to try to find this perfectly theoretical language that, is perfectly analyzable and all that, but say, because often enough, you get away with using these features because your data is actually not that complex and you can actually do the exploration. It's use case oriented, and contrary to some other tech in the space, right, it covers the whole application lifecycle, right? So Cypher is about reading data, it's about writing data, but it's also about modifying your schema, right? So it gives you the full package. I hope, at least if you know Cypher a bit, you can see that, right? Maybe I should do a quick, who thinks that this is a correct description of Cypher? Let's try that one, actually. I'm scared, but fair enough. So perhaps a different, look at all of this, is that's why I was also rushing through it a bit, is how do you actually achieve that? How do you make it happen that you end up with these traits in your language design? It's nice to put that on a slide, right? The different thing is, how do you do that? And so a little while ago, we actually stepped back and said, maybe we should think that through for ourselves. And if you know a bit about language design in the Python space, they have this thing called the Zen of Python, which is like this little list of one-liners describing kind of how you should go about language. And we did the same for Cypher, right? And this is what this talk really is about, right? So let's do that. We call it the guiding philosophy, because we didn't want to steal the name from Python. That felt like cheap, kind of. So yeah, as I already said, Cypher is a high-level graph query language, right? So it aims to give you the right level of abstraction to express the needs of your application, right? To really think in terms of your domain, and yeah, to not be too technical, but to also be a language that's good to use then from an implementation point of view, right? And then I think that one is really important and undervalued in other technology, right? Design should be validated by user needs, right? So whenever we do a change to the language, we really start by what is the actual real-world problem that needs to be solved here, right? What's the actual addition? So in a consequence, this means that we somehow might not go, even though it might be immediate to go to a more generic solution, to kind of, you already see the pattern, you could go a bit more abstract. We often don't do that, right? Because of this, because we say, okay, this is the use case we understand, that is the use case we want to solve now, right? And then you can take the next step after. So then here we have a bunch of essentially comparisons, right? And I like those a lot because often you have these fights about syntax and things like that, and then you can just go through this list and kind of, yeah, okay, where do I end up, right? And one is readability is better than terseness, and I think that's seen in Cypher, right? Because, and that goes back to that initial point about human readability, right? If you look at the Cypher query, if you have a bit of a technical background, I would claim you have a fair chance of at least getting a loose idea of what it's doing, right? Of course, there are semantic, details always in a language like that, right? So then, I mean, this is essentially just learning the lesson of the database industry for 30 years of SQL, right? Declarative is better than imperative, right? So a query language should be about what you want, not from the database, not how the database goes about doing that, right? And that's all, the whole purpose of having query planners, of being able to later create indexes and have your database pick that up and give you a different query planner and all that. And that's reflective here. And that's the kind of implementation side of that little comparison. The other side of it, again, is this is, of course, also, again, about the domain side of things, right? Because as a user, as someone working with a business problem, you shouldn't think about how your tech actually gives you what you want. You should think about what you want, right? Because that's where your focus should be, right? Yeah, then the next one, composability is better than complexity. So this plays again into the fact, like, initially Cypher didn't have a this clause, right? You could just find a pattern and then do a bit of filtering, and that was that, right? And then eventually we introduced this so that you could kind of combine multiple things together, and now we have union, and I'm sure that's not the end of it, right? So that's one view to think about composability. And another way to think about composability, right? Once you have understood graph patterns, right, you can use them in different contexts. And graph patterns are very, very ubiquitous in Cypher, right? You have them in matching, you have them in when you create data, right, in the create statements we saw initially. And you also have them in predicates, right? You can also say, okay, find me this node in the graph that is connected in such and such a way. So, which is, I think from a theory side, commonly goes under reachability queries, right? So there again, you would reuse patterns. And here, from a language design point of view, the reason to do that, to kind of shoot for this goal, is to reduce complexity, but also to leverage learning, right? I mean, Cypher, despite all our best efforts to make it usable, right, and really, really pleasant to use, is a language that's growing in complexity. And this rule is there, right, to kind of push back against that, to try to, can we reuse something existing, to kind of reduce the cognitive burden that the user needs in order to pick up the language, right? Because that's always the fight that you have in a query language, right? You can, of course, keep piling up features on features and features. Yeah, so another one, explicit is better than implicit, which I think is, you could argue, a bit of a corollary to readability is better than terseness, right? So there is nothing hidden, right? You look at the query, you go through it piece by piece, there are not too many implicit assumptions. By looking at it, you can figure out what it does, right? And then perhaps that is, I think that is the key defining trait of Cypher. I mean, a lot of these things you could say for other languages as well, obviously, right? Visual is better than textual, right? And we try to do that. It's not always easy, but I think with patterns, we have really a stake in the ground on that, right? And we try to kind of keep going on that side. And to me, what it also kind of implies by extension is a certain minimalism, right? Because you have to keep, if you have to keep that in mind, right? You want to keep patterns readable, that actually does inform language design, right? Because then you say, yeah, maybe we could introduce this new thing in relationship patterns, right? And it would make them more powerful. But now, all of a sudden, it would be like, you know, it wouldn't be visual anymore, right? So you would kind of lose this flavor of the language, right? So I think there's a key thing there. So I would guess the first one is kind of obvious, familiar to users of SQL and inspired by Python. Is that obvious in the crowd? So what is, I mean, SQL, that part I think is easy, right? We have the same kind of clause-based syntax that SQL has. Maybe a bit more modern take on it. The inspired by Python comes from two directions, right? One is whenever we have semantic questions, kind of corner cases, details that usually pop up as a ticket that no one has thought before, right? Like, what is that actually supposed to mean? These type of questions do happen, still happen today. Then we often go down to Python because they have often some very nice and very simple solutions to kind of get informed. And the other side of thing here is actually Cypher has a certain syntactic simplicity about it. Perhaps that's easiest seen by the fact that they use white space instead of curly braces, for example, right? So we try to have the same kind of syntactic simplicity, right? That's kind of the goal, right? Anyways, and then the last but not at all, oh no, this is not the last one, sorry. So then the other point is consistency is important, right? We kind of talked about that already a little bit. Learning one part of the language should help understanding other parts, right? I mean, that's always nice if you achieve that, if you can kind of transfer your knowledge because you understand Cypher, we add a feature and you have a question, and then in your mind you can kind of say, okay, it probably works like this, right? Because the language kind of fits together. We try to achieve that. That's actually a hard one. And prefer a single way to do things kind of goes together with that, right? I have to put prefer because Cypher as a language too complex, right? We're long past the point that there's only one way to express a query, right? That you don't get that with a language of that kind of level of expressivity. You can't have that, right? Would be nice, but yeah. So last set of guidelines that we kind of try to follow through is errors should never pass silently unless explicitly silenced. I mean, I guess that's a generally good practice, right? If it is for language design or for application programming, you want that basically. So then the next one, right? That captures, I think, quite a bit of the gist of how we're working. Progress is more important than perfection, but consideration beats hastiness, right? Because you have to balance between these two things, right? You can spend hours in endless discussions about the finer points of syntax and semantics, right? With the net effect that you guys never get a new Cypher feature, right? And that is, of course, not very desirable outcome, right? But you can also rush things. And whenever we rush things, right, I mean, we try to do great care to give backwards compatibility, right? When we make a change, right, we don't break it in the next version. We say, sorry, we have to change something, we deprecate it, and eventually it goes away, right? But it also means whenever we rush, we have to go through that whole process with all the effort it implies, changing training material, changing documentation, right? So consideration is also important. And for me, a really nice example for that is in Neo4j, we did in 3.0, we did procedures, right? With call. And the initial design for procedures would have only allowed you to execute procedures, just a procedure, not within a larger Cypher query, due to essentially timing constraints and how that whole project was run. And then it became obvious that it would be really, really good to do that, right? That the kind of the power of the language would improve massively if you could do procedures within a query, right? But as the kind of time was closing for feature freeze, right, we had some semantic points, and actually we're still discussing kind of tweaking that a little bit because of these points. But then we said, okay, let's run with our current design because the value of getting that out is so much more higher than trying kind of discussing this to perfection, how it should actually fit into the language, right? So yeah, Don't leave holes in the specification that allow the implementation to leak through. So yeah, that's basically whenever we discover a gap, right, we close it, and we close it in such a way that it makes sense from the viewpoint of the language and not from the viewpoint of the implementation. Right? That's the primary focus, right? So one thing, if you're following our pull request that has just popped up that is of that flavor, we're currently having a discussion whether we should allow null as a key in a map. You can do a quick round. Who thinks that's a good idea? No, right? Okay, because we have some people actually, some customers actually arguing that's a good idea. So, and that is clearly, right, no one ever designed this, right? That is just an implementation artifact, and we have to sit down and kind of discuss it. What does it mean? Are we going to immediately prohibit it? Are we just going to deprecate it now and remove in a later version? Or do the opposite, right? Maybe it has merit, right? And last, surely not least point, right? Follow these rules unless there's a better way, and never be too proud to throw something away. I think that's a good advice for any engineering. So, design process. Since I have a second deck, I want to wrap up a bit. So the way we work these days is we write documents called CIPs, Cypher Improvement Proposal. That's the kind of the name of the document, and the whole process is called Cypher Improvement Process. Yeah, and there's actually a template. If you go to the Open Cypher website, you'll find that. And the kind of the common structure is motivation and a bit of background, right? That's where you kind of come from the use case. What is the actual thing that you want to achieve? Then there comes the actual proposal, you know, syntactic, semantically. We really value having examples in proposals, because that really makes it much easier to talk through these rules, right? I mean, if you want to go through this whole design process I just discussed, right, you have to look at examples and kind of say, does this really, you know, is this really Cypher, right? Or is this weird in some way? Or could it be better, right? And of course, what others do, you know, and what are the benefits of adopting the proposal? What are the caveats of adopting the proposal, right? So that's usually the initial document. And then, of course, discussion ensues, right? And then after some time, and we'll revisit this process actually in a bit in the second part of the talk, right? We eventually, you know, accept a proposal, and that just means that we kind of agree that we want to do this change in the language, right? And then after that, there's actually a second step that we're currently also, I think, working a bit on, how we're going to execute on that process-wise. And that's actually updating the Open Cypher grammar, updating the TCK, yada, yada, yada. So there are some, after we've accepted a proposal text, right, there's like a second stage of updating all the specification artifacts, essentially. Yeah, this one. So to just give an idea of things that we've been lately doing in the CLG according to this process, right? Here's some features that we kind of decided on doing that are not implemented at this stage, right? Because we really approach this from a specification point of view, all of this. And one is mandatory match. That's a very simple thing, but it's really lovely driven by a use case, right? If you have like a lot of matches in your Cypher query and all these pick out individual nodes from parameters, right? And then somehow you get invalid parameters in, so it doesn't find anything, right? The net effect that you get from that is you don't get any result from your query because your cardinality gets killed, right? And then what you do is you go down, you open up a debugger or whatever you do, and you find out which of your parameters actually didn't give you something back, right? And what mandatory matches, it's a way of saying this pattern must match at least a single row, and if it doesn't, you get an error pinpointing you exactly to what didn't match, right? So that's a tiny thing, but I think it's actually practical for application developers. So, and then maybe that's a bit more obvious, right? We're working on subqueries, and here you see two examples of them, right? One is exists subqueries, right? So we do a regular match where exists, and then you do again a pattern on the inside. That's very similar to how pattern predicates work today, but in an exist subquery, you can bind new identifiers and filter based on them. And that is something that you cannot do today in Cypher, in a pattern predicate, right? And then the second type of subquery is actually full subqueries, and the syntax is likely going to be kind of like that. So you do match curly, and then inside you can do a subquery with all the things you can do in a subquery, right? And since I'm running short on time, I'm not elaborating on what that means, but you can do a lot more by having that. So other things we're also doing that's kind of like a different track is more foundational. So we're also writing SIPs covering areas of the language, essentially, just in order to write down what are the semantics actually are, right, that we have today. And this is where we find all these holes, all these things where the implementation shines through, and then having quite heated discussion of what the semantics should be and should we change it, and all these things. And things we've covered there lately is coercion, comparability, that's actually a really, really big topic, and procedure calls. And last not least, to end this talk, if anyone feels motivated now to write a SIP, we would love to see that, right? Cool. Yeah, and I'd like to end with just one quote to kind of go just a tiny bit against that. We really want to see that, but the hardest part of design is keeping features out, right? So we have to counterbalance sometimes.